Venkata Rao, Professor of Mechanical Engineering, IARE, Hyderabad. I discuss about the topic transportation model. Topics to be covered: introduction, classification, formulation, feasible solution, optimum solution, balanced type problem, optimum solution for unbalanced degenerate problem. Transportation model is a special type of linear programming problem in which goods are transported from a set of sources to set of destinations depending upon the availability and requirement at minimum cost. The name of this model derived from transport to which it was first applied. It is also used for plant location, product mix, and many other problems. The main objective of transportation is to minimize the cost of transportation while meeting the requirements at the destination. Types of problems. So when supply is equal to demand, then the problem is called balanced type. If supply is more than or less than the demand, then the problem is called as the unbalanced type problem. So in this there are two types of solutions are there. One is the feasible solution, another one is the optimum solution. The feasible solution can be obtained by using three methods. One is the northwest corner rule, next one is lowest cost entry method, and third one is Vogel's approximation method. Mathematical formulation of transportation problem. Let there are m sources and n destinations. Let ai be the number of units available at source I. Let bj be the number of units required at destination j. Let Cij be unit transportation cost from source I to destination j. Let xi be the amount transported from source I to destination j. Now the problem is to determine the values of xij satisfying both availability constraint sigma xij is equal to ai for I is equal to 1 to 3m, and requirement constraint sigma xij is equal to bj for j is equal to 1 to n, and minimizing the cost of transportation z is equal to double sigma cij xij. Example: find feasible solution to the following transportation problem in which cell entries represent unit cost. So in this, factories F1, F2, F3 and warehouses W1, W2, W3, W4. So here unit transportation costs are given. So 19 means the cost required to transport the goods from factory 1 to warehouse 1. Similarly, 30 indicates that the cost required to transfer the 1 unit of the product from factory 1 to warehouse 2. And here capacity is 7. So at the factory, total number of units available are 7. At the factory 2, total number of units available are 9. At factory 3, the total number of units available are 18. But the requirement is at the warehouse 1, the requirement is 5, warehouse 2, the requirement is 8, and warehouse 3, the requirement is 7, and at warehouse 4, the requirement is 14. So total capacity is equal to demand, because the total capacity is 34 and total demand is 34. So it is a balanced type problem. So this can be solved either by using the Vogel's method or lowest cost entry method or northwest corner rule method. So first we will discuss about the northwest corner rule method. So in this, first select the northwest corner, that is the first cell, and allot as much as possible and cross out the row or column satisfied. Repeat the same procedure until all requirements are satisfied. Finally, enter all allocations in a separate table. The table gives the final entry, all allocations in a separate table. The total cost can be obtained by multiplying each individual allocation by its unit cost and adding all. Now, in the given problem, the first cell, that is the northwest corner, is corresponding to 19. So here the demand is 5 units and requirement is availability is 7 units. So we can assign 5 units here and we can cross out the column satisfied. So next northwest corner is 30. So here availability is only 2 and demand is 8. So we can assign 2 units and cross out that row. The next so the next northwest corner cell is 30 in the second row and demand is 6 units and availability is 9 units. So allot 6 units and cross out the column satisfied. So the next northwest corner is 40 and we can assign 3 units because only 3 units are left over and cross out that row. The next northwest corner is 70, so that we can assign 4 units and the remaining cells are 20, that is 14 units. Now you can check up whether all the units are allotted or not. In the first row 5 plus 2 7, in the second row 6 plus 3 9 and third row 4 plus 14 18 units are allotted. So total capacity is utilized. Similarly in the demand, first column 5 and the second column 2 plus 6 8, in the third column 3 plus 4 7 and fourth column 14 units. So now enter all the allocations in a separate table. Now this table will give the feasible solution. The total cost can be obtained by multiplying each individual allocation by its unit cost. Now the total cost is equal to 19 into 5 into 30 into 2 plus 30 into 6, 40 into 3 and 70 into 4 and 20 into 4. So the total cost is 1015 rupees. So the next method is lowest cost entry method. First select the lowest cost element and allot as much as possible and cross out the row or column which is satisfied. Repeat the same procedure until all the units are satisfied. Finally, enter all allocations in a separate table. The table gives the feasible solution. The total cost can be obtained by multiplying each individual allocation by its unit cost and adding all. Now, see, in the given problem, the lowest element is 8. The lowest element is 8 and the requirement is 8 units and the demand is 18 units. So we can assign 8 units and cross out the corresponding column. After 8, the next lowest element is 10. So we can assign 7 units and we can cross out that row which is satisfied. The next lowest element is 20 and we can assign 27 units because the available units are only 7. So assign 7 units and cross out the column. So the next lowest element is 40 and allot 7 units to it and another lowest element is 40. Again we can assign 3 units. Now you can check up how many units are allotted. In the first column is concerned 2 units plus 3 units, 5 units are allotted. In the second column is concerned 8 units are allotted and third column 7 units and fourth column 7 plus 7 14 units are allotted. And first row is concerned we allotted 7 units. In the second row we allotted 2 plus 7 is 9 units and third row 3 plus 8 plus 7 totally 18 units are allotted. So the total demand is equal to total capacity. Now enter all the allocations in a separate table. The table gives the feasible solution. Now the total cost can be obtained by multiplying each individual allocation by its unit cost. So 10 into 7, 70 into 2, 40 into 7, 40 into 3 plus 8 into 8 plus 20 into 7 is 814. In the previous case we got 1015 but now it is 814. The next method is Vogel's approximation method. So the procedure for this Vogel's approximation method is find the difference between the next lowest element and lowest element in each row and write on the right side of the matrix. So this difference is called as the penalty. Similarly, find the difference between smallest element, next smallest element, and smallest element in each column and below the corresponding column. Now, allot the units corresponding to the highest penalty. Now, select the row or column corresponding to the highest penalty and allot the units to and select the lowest element corresponding to the highest penalty and allot as much as possible. So repeat the same procedure until all the requirements are satisfied. So if any row or column is satisfied, first cross out that and repeat the same procedure until all the requirements are satisfied. Finally, enter all allocations in a separate table. The total cost can be obtained by multiplying each individual allocation by its unit cost and adding all. Now, you see the problem here. In the first row, the lowest element is 10, next lowest element is 19. So, the difference 19 minus 10 is 9. That is corresponding to the penalty in the first column. Next, in the second row, the lowest element is 30, next lowest element is 40. So, the penalty is 40 minus 30 is 10. In the third row, the lowest element is 8 and next lowest is 20. The difference is 12. So, the penalties are 9, 10 and 12. Corresponding to the columns, the lowest element is 19, the next lowest element is 40. The difference is 40 minus 19 is 21, that is 21. Second column, the lowest element is 8 and next lowest element is 30. The difference is 30 minus 8 is 22. In the third column, the lowest element is 40, the next lowest element is 50, so the difference is 10. Similarly, in the fourth column, the lowest element is 10, next lowest element is 20, so the difference is 10. Now, the penalties are 9, 10, 12 corresponding to the rows and columns 21, 22, 10 and 10. Now, select the column corresponding to the highest penalty. So, the highest penalty is 22. Here, an arrow is marked here, so that indicates that is the first allocation. So, corresponding to this highest penalty, the lowest element in that column is 8. So, now you can assign 8 units because the demand is 8 but the capacity is 18. So, allot 8 units and cross out that column. Next, when the column is cancelled, again find out the penalties on the row side. Now, the row side penalties are again 9, 20 and 20. In the previous case, the penalty is 21. So, the highest penalty is 21. Now, select the column corresponding to this highest penalty. So, the lowest element is 9 and you can assign 5 units. So, this column is satisfied. So, again cross out this first column and again find out the penalties on the row side. So, now the penalties are 50 minus 10 is 40, 60 minus 40 is 20. So, the highest penalty is 50, so that you can assign the lowest element is 10, you can assign 20 units. So, and cross out that column, cross out that row. Now, again find out the penalties. The penalties from the row side is 10 and 50. So, the highest penalty is for 50, the lowest element is 10. So, you can assign 2 units and the remaining cell is 60. So, assign 2 units. So, finally, enter all the allocations in a next table. So, this is the allocation table: 19, 5, 10, 2, 47, 62, 8, 8, 20, 10. So, the row side are balanced 7, 9, 18, column side 5, 8, 7, 14. So the total cost is again by multiplying each individual allocation by its unit cost and adding all. So 19 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2, 8 into 8 plus 20 into 10, that is 779. This is the solution corresponding to the Vogel's approximation method. So next one is the Modi method. It is used to find out the optimum solution. So in this Modi method, first find out the basic feasible solution by any method and check whether the basic feasible solution satisfies the initial two conditions. Conditions one is the number of allocations must be equal to m plus n minus 1, where m is the number of rows, n is number of columns. Then if number of allocations is equal to m plus n minus 1, the condition 1 is satisfied. The second condition is the allocations must be in independent position. That means these allocations should not form any loop. A loop means it consists of at least 4 horizontal and vertical lines with an allocation at each corner. In turn, it is a joint of horizontal and vertical line. If these two conditions are satisfied, then we can perform the optimality test. So these are the different types of loops. So first loop, it is having 4, and in the second loop it is having 6 allocations. In the third loop, these are the different types of loops. Then optimality test. So for performing the optimality test, first write the allocation matrix for finding UI and Visa values. For finding UI and Visa values, initially take any value to UI, better to take 0. For any row, convenient rule is select the row or column with maximum number of allocations. Next, find out the remaining values using the formula Cij is equal to UI plus Vj. Next, write the matrix for UI plus Vj for empty cells, and then write the matrix for Cij. Next, calculate Cij minus UI plus Vj for empty cells and enter in the matrix. If all the values of Cij minus UI plus Vj are positive, then the solution is optimum. Otherwise, make it optimum by transferring the units to the most negative cell by forming loop and again check up for optimality. Now, solve the following transportation problem in which cell entries represent unit costs. So, the problem is given. Now, first find out the initial feasible solution by any method. Better to find out the Vogel's approximation method. In the Vogel's approximation method, we have to find out the penalties. In the first row, the penalty is 2. That is, the lowest element is 4 and next lowest is 2. 4 minus 2 is 2. In the second row it is 2. 3 minus 1 is 2. And third row, 5 minus 4 is 1. And fourth row, the penalty is 1. And corresponding to the column, the penalty is 1 corresponding to the first column, and the penalty is 1 corresponding to the second column, and corresponding to the third column, the penalty is 1. Now the penalties are 2, 2, 1, 1. Now you can select any one, because both are equal. You can select any one. Now I have selected the second row because it has having the lowest element. So the lowest element is 1, and allot 8 units and cross out that row. Next, again find out the penalties in the column side. The column side penalties are 1, 2, 2. So again 2 2s and one more 2 is there. Now you can consider these 2 and assign as much as possible. The lowest element in this row is 2, and you can assign 5 units and cross out that row. Again find out the penalties in the row side. Now the penalties are 4, 2 and 5. So now select the highest penalty 2 and assign maximum number of units. So 2 is the lowest element, you can assign 10. So the remaining elements are allotted to the leftover cells. So this is the initial feasible solution, and the cost corresponding to this is 80. So we allotted in the first element 5 units, in the second row third element 8 units, in the third row second unit 4 elements, and fourth row so first element 2 units, second element 2 units, and third element 10 units. So again we have to check up whether it is balanced or not. Total capacity is utilized or total demand is satisfied or not, we have to check up. Then so next we have to find out whether it is the optimum solution or not. For that we can use the Vogel's Modi method is used to find out the optimum solution. So now first find out UI and Vj values for occupied cells. Next find out remaining values using Cij is equal to UI plus Vj. Next find out UI plus Vj for empty cells, and then calculate Cij minus UI plus Vj for empty cells. If it has all positive values, the solution is optimum. If any one is negative, then transfer the units to the negative cell by forming a loop, and again test it for optimality. So the allocation matrix is here. Now find out UI and Vj values. So here I have written UI, here I have written Vj. So initially I have taken UI is equal to 0 corresponding to the third row, corresponding to the fourth row, and the Vj values are calculated. Here this is 0, so this is 1. Cij is equal to 1, UI is equal to 0, so Vj is equal to 1. Corresponding to this, Cij is equal to 6, UI is equal to 0, so that Vj is equal to 6. Similarly, 0 UI is equal to 0 and Cij is equal to 2 and Vj is equal to 2. So next Vj is equal to 1 and Cij is equal to 2, so that you can find out UI is equal to 1 here. This is 1 and this is 2 and this is 1. Then you can find out this value is -1 and this value is -2. So now we found all UI and Vj values. Next, write the values UI plus Vj for empty cells. So here UI value is 1 and Vj value is equal to 6. So UI plus Vj, the green numbers 7 indicates that is the UI plus Vj for a empty cell, because 7 is empty cell because we are not allotted to this. Next one is 3. So 1 plus 2 is 3 for this cell, and 1 minus 1 is 0, and 6 minus 1 is 5, and 1 minus 2 is equal to -1, 2 minus 2 is equal to 0. These green numbers indicates that UI plus Vj values corresponding to the empty cells. Next, find out Cij minus UI plus Vj. Now Cij value is 7, UI plus Vj value is 7. So Cij minus Uij plus Vj is equal to 0 here, and here 4 minus 3 is equal to 1, 3 minus 0 is equal to 3, and 3 minus 5 is -2, and 5 minus 6 is -1, 7 minus 7 is equal to 0. The red numbers indicates that these are the Cij minus Ui plus Vj values. Now here we are having most negative value is -2. Now that means we have to transfer the units to this cell in order to optimize the solution. Now I formed the loop. So I transferred lambda units. So -2 corresponding to plus lambda. So when plus lambda is added, then we have to subtract that minus lambda. When minus lambda is here, then we have to add plus lambda, and if here plus lambda is added, minus lambda should be there, because the values should not change either in the rows or in the columns. So next we have to decide the value of lambda. So the maximum number of units we can transfer is only 2, because here 6 is having 2 units, 2 is having 10 units, 1 is having 8 units. In the loop, the maximum possible units to transfer are only 2. So I am transferring 2 units to the element 2. So now this is the final allocation. After forming the loop and transferring the units, the solution becomes 5 units here, 3 units are here, 6 units and 7 units here, and 2 units here and 12 units here. And the corresponding cost is 25. So this is the allocation. Then we are transfer the units, and this is the initial solution. Again, we have to check up for optimality. After transferring the units, again we have to find out UI values, CIJ values, and UI and visa values we have to find out. After finding out UI and visa values, we have to find out UI plus visa values. So here UI plus visa values are 5, 3, 0, 1, 2, 4 are the UI plus visa values. CIJ values are 7 and 3 and 5 and 7 and 2, 6. So 7 minus 5 is 2. That is CIJ minus UI plus visa value. 4 minus 3 is 1. 3 minus 0 is equal to 3. 5 minus 4 is 1. 7 minus 5 is 2. 6 minus 4 is 2. So all the values are positive. The solution is optimum. So the total cost now you can obtain is 76. This is the in the previous case, in feasible solution, the total cost is 80, but now it is reduced to 76. This is the optimum solution. Next. So another problem here, the demand is not equal to supply, and also we want to maximize the profit. But transportation problem can be used for the maximization as well as the minimization. If the given problem is maximization, so we have to multiply all the elements by negative sign, and then we have to proceed. We can use the same procedure to find out the solution. So it is the unbalanced type, because the demand is the supply is only 300 and the demand is 305. So add a row or column with zeros are the corresponding units. So in the third row, I have taken zeros corresponding to the unit transportation cost, and the number is 5. So first of all, I have to make capacity is equal to demand. If the capacity is not equal to demand, then it is not possible to find out the solution. So first of all, we have to make the demand is equal to capacity. So for that purpose, I added a row. Then I multiplied all the elements by negative sign in order to convert the minimization problem into maximization. So again, first find out the initial feasible solution by Vogel's approximation method. So in the Vogel's approximation method, so we have to find out the penalties. So in this case, the lowest element is minus 130 and next lowest is minus 85. So minus 85 minus 130 is 45. So similarly, find out the penalties this side. So the lowest element is minus 90, next lowest is minus 50. So the penalty is minus 50 minus of minus 90, the penalty is 40. Similarly, in the second column, the penalty is 20, third column, penalty is 30, and fourth column, the penalty is 25. So now the highest penalty is 45. So allot maximum number of units corresponding to this row. The lowest element is minus 130. So allot 100 units because the demand is 100 and the capacity is also 100. So allot 100 units and cross out that row. Then 100. Next, you can find out the penalties this side. So after cancelling the first row, the penalty is 0 minus 90 is 90, 0 minus 90 is 90, 0 minus 100 is 100, 0 minus minus of minus 110 is 110. So now allot the select the highest penalty, and corresponding to the highest penalty select the lowest element and allot as much as possible. So the lowest element is minus 110, we can assign 30 units here. Here we can assign 100 units, we can assign 70 units. So 5 units are left over, that 5 is also assigned. So this is the final allocation. This is the final allocation. Now we have to check up whether it is the optimum solution or not. The total cost corresponding to the initial feasible solution is 31,600. Now we have to find out the optimum solution using Modi method. So for that you have to calculate UI and Vj values. UI is equal to 0 corresponding to the first row, and we can find out the remaining values by using that 0 value. So UI value is 0, Cij is minus 90, so that Vj is minus 90. So 0 minus 90 and again it is minus 90, 0 minus 100 minus 100. So first in this case the number of allocations are not equal to m plus n minus 1. So m plus n minus 1 is equal to 6. Number of allocations are only 5. So in order to make number of allocations is equal to number of allocations is equal to m plus n minus 1, we have to select the lowest element and allot epsilon number of units to that cell. So I have taken minus 100 as the next lowest element. While selecting the next lowest element, the loop should not form. So if loop is formed, again it is not possible to perform the optimality test. Then next we have to find out UI plus Vj values, and then Cij values, and then we have to find out Cij minus UI plus Vj values. So here Cij minus UI plus Vj values are here minus 120 and minus 120, minus 40, 0, minus 10, minus 20. So Cij minus UI plus Vj is 70, 50, 55, 0, 10, 20. So these are the values calculated. UI plus Vj values are calculated, and then Cij minus UI plus Vj. Cij value is minus 50, UI plus Vj value is minus 120, Cij minus UI plus Vj value is equal to 70. So similarly here minus 70 minus of minus 120 is 50, minus 85 minus of minus 140 is 55. So again 0 minus 0 is 0, 0 minus 10 is 10, 0 minus 20 is 20. So all the values are having positive values. So the solution is optimum, and the total cost is obtained by multiplying the corresponding elements by the number of allocations. So 90 into 70, 90 into 100, 110 into 30 plus 130 into 100, that is 31,600. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.